them in the first one. So that was my first piece. I wanted to describe what we're communicating and why. The second part of this was where I wanted to talk about cyber and give this introduction to the cybersecurity environment. So what do we care about, and what do some of the words actually mean in this environment? So this picture here is a public picture that's well publicized about the number of cyber attacks we've had over in the US over the number of years. For everyone's, Ukraine was one of the well publicized attacks, which really showed us that attacks on infrastructure that have a physical impact are no longer really theoretical. But there's some other good examples that have happened in the US. I think it's the Bowman Dam was one of the ones that were interesting because, as it turns out, we believe that was an attack on a dam that was the wrong dam because it shared a name with another much larger situation, but the name's wrong dam but good try was the thing that people said. An airport was a teenager, I think Massachusetts airport, and would include a teenager managing to break into systems. And then we move forward to one of the more recent issues, which includes the Triton Attack, which was probably one of the first examples in the US that we'd seen where loss of human life was considered an actual acceptable outcome to that event, which is an unfortunate big step forward in what we look at in these systems. So there's a big difference here between a ransomware attack, where there isn't necessarily always a risk to human life. There's a risk to business systems, stepping up to an actual attack on control systems that could have an intentional or unintentional consequence of the loss of human life. So the scale of things has been increasing over time. So if we step through, I forgot those pictures were there, sorry. We step through to the next one. So Dan Coates, former Director of National Intelligence, had given a public discussion testimony about a year ago, or I think it's 2 years ago now, on the capabilities and intents of Russia and China to map our infrastructure. Similarly, everyone's probably heard about the election system worries, and the scale of attacks are growing. And so it's something we need to be more intelligent about and more intentional in how we manage those cyber physical systems. And so on the transmission side, there's been a lot of work on how that's done, because transmission is obviously the bulk system. It's a much a small attack is a much larger impact. But as we start to link together distribution system controls, operational systems, ADMS, as I talked about, we need to consider the bulk impact of the distribution system and how to both get all of the benefits from the distribution components while also not slowing down their ability to be deployed, but also protecting the critical infrastructure from potential adverse impacts of those attacks. So, taking a bit of a step back to the basics. Next slide, sorry. If we think about cyber, like I said, we need to think about communication system. There's a large difference between an intrusion into the industrial control system versus the IT network. And there are rules in place for how those two are not meant to be connected, but in many cases, there's still ways that happens. And also considering things like malware versus lockouts versus controlled disruption to the system needs to be seen on different scales of how we must work with it. So next slide. So I mentioned IT and OT. Almost everything I've talked about today is all on the OT side. We can't deal with them on the same level. IT does include a lot of business systems. It is critical to managing data, but it's not generally where the real-time sensing systems live. It's not where operational systems live. The types of things that are seen here a lot are to do with ransomware, locking people out of systems. But again, the availability of the system is generally not as critical, and you can reboot without losing control of a device or taking it offline entirely. Where what does live in the IT network is part of the AMI network, which is to do with customer privacy and human privacy. And all those kinds of items are sitting in the IT network. So depending on what your biggest concern is, IT is either the most critical thing or it's lesser than the OT network. So it depends on what you're worried about. If human privacy, for example, in the medical field, is the number one worry, then IT is your priority. If you're worried about control processes, that's where OT lives. So OT network manages physical as it sounds like, things that are used for operations. priorities are generally safety, continuity, and fault tolerance. It's real-time systems that are working with here. Again, human safety is always kind of the paramount thing that everyone considers first. The systems are often diverse in the OT network. They're often proprietary as well. And software updates typically need to be done through the vendor. So if you consider things like distributed resources, you probably have an inverter in your house that is developed by one vendor, and then there's another device that's talking to it that's developed by another vendor. The vendors generally control how those updates happen. You have to communicate to their network to get new firmware. And so it can be a complicated interaction of systems, and that's where interoperability becomes critical. And also, OT networks can be isolated. You want to isolate your OT network, but pieces of it can be isolated in different places. So often recently, and why we're talking about this is and especially around the distribution system recently, a lot of the IT ideas of how you secure a network are being applied to the OT network and are not generally actually adapted to the requirements of the system. So there's a lot of new thinking that needs to happen about that control. So talking a little bit about the frameworks we use on the next slide, NIST, or the National Institute for Standards and Technology, I tend to get the S wrong. They developed a framework to help infrastructure and industry understand the needs they have for cyber. And in this framework, they talk about different classes of protection, which include identify, protect, detect, respond, recover. These 5 classes are essentially meaning to help you understand what protections you need to put in place for that different type of event, or what the different functions are in each world. So if we step through it, identify is actually the planning step. So knowing, and sorry if you could move to the next slide, knowing what you actually have and what your risk is. So we say know thyself. So identify what your actual assets are, your data, the people that are attached to it and using it, and also understanding how your network behaves, so you actually know when it's not behaving the right way. So if you suddenly have a flood of data coming in from your smart meters, for example, then is that normal? Did something actually happen that caused that? For example, there was a large event was happening and everyone had an event that got sent back all at the same time. That's one thing. That all happening without an event related is another. So understanding how your network actually behaves is a critical piece. And also understanding what you're defending against. So the risk that you're at, identifying where the vulnerabilities are and the potential impact. And so the categories of work that go into this include sort of risk assessment and management, business environments, looking at asset management, understanding what's there, knowing how it works, and you can't defend if you don't know what's actually on your system. So another one that people may have heard about recently is the supply chain risk management as well. That's where this falls into identifying what you have on your system and how it's being used. So next slide. So protection of your system is essentially, at the very basic level, nothing is actually perfect. Protection does make it harder though for people to get into the system, and at a basic level this is where you have things like encryption, network segregation and segmentation, which is where when people say IT and OT must be separated, that's where this is. Authenticating users, so people being able to, when we talk about double authentication on systems, authenticating is actually a very good way to stop people getting into your system. Maintaining an incident response plan and recovery plan means that once something happens, you actually know what to do about it. So it's all about planning for these kinds of events. Also in protection, you can reduce the attack surface and make sure you're actually up to date on devices, because I know I ignore updates in my computer quite frequently. Imagine the whole utility was doing that, because sometimes those updates are disruptive and annoying. So making sure you are patching your systems and looking for those vulnerabilities are important. So in the protect world, we have things like information protection processes, data security, actual training, making sure staff know what to do is pretty critical. Identity management, again, being a big one, and other protective technologies in here. There's no system that's perfect. There's no system that is 100% impenetrable. But there's always a human factor in lots of ways. But the objective here is to make it much harder for an adversary to get into the network. So next, sorry. So kind of like you have an immune system, knowing what you actually have happening is one of the keys to actually fighting it, assuming you're going to get infected. So how do you actually, and it's probably not the best way to put it at the moment given what's been going on, but assume that your system is going to catch something. Assume you've got it. What do you do once someone has got into the system? Well, the best thing to do is to find it quickly and respond to it. So again, this is back to establishing your baseline behavior, keeping libraries of known events, monitoring for unauthorized connections, and being able to find those vulnerabilities. Also reporting. It's kind of important here that you allow others to benefit from your experience. So when you're reporting, there's incident response people all over the globe of response, including even sort of Army Cyber Command, for example. They have processes in place for large-scale incidents that involve utilities. So making sure small incidents are reported is how those things get prevented. So detecting anomalies on your system, continuous monitoring and processes. So again, I'm not trying to say this to sound scary, but people will find a way to get into the system, but catching them quickly is a way to prevent things from spreading. So next. So one of the last things we talk about is response and recovery. Again, response is all about mitigation, sharing information, for example, through CISA, CISA, sorry. They're the nation's risk advisor, the US risk advisor for these kinds of systems, ran through DHS. Being able to do root cause analysis, if you found something new in your system, reporting it, forensic analysis on the larger system, and then being able to mitigate those new vulnerabilities that you've identified. And where this is kind of important in response is also when you consider things like inverters and DER. There's a whole bunch of new issues that are coming into play here. And so responding to new issues and being able to have an accurate, what are you going to do if this happens, is really important. So next. Lastly, we have recovery. It can take a while. One of the programs going on just now with DARPA is all about how a utility would recover from a 30-day outage that was caused by a large-scale cyber attack. And a lot of what they've learned in here is about the recovery plan more so than the actual everything else that happened up to that point. Power people and cyber people working together is one of the big targets here. And so it can be time consuming, but at some point, for example, if you're cleaning up a substation after an event, your cyber team need to come in, but they also safely need to be able to talk to the different systems in there. They need to be able to pull out what's happened, forensically analyze it, and then help clean up the system before the power gets switched back on, for example. So you can imagine that turning on power to a device that has been compromised is not necessarily the smartest thing to do because it may irrecoverably damage the system. So making sure all the activities up to this point are performed, but they're always having a plan in place for recovering, what you're going to improve after that point, and what the communication system will look like following the event that's happened. So it's a step-through process, but there's work going on in all areas to understand. On the next slide, there are some common, like the simplest thing is there's a lot of common intrusion paths that it's not actually always the most complicated way that you think is happening. It's not generally always, it can be a kid sitting in a basement as opposed to whatever else you think is happening outside in the outside world. Everything to do with sort of stealing passwords. Password strength is pretty important. Leaving things like admin and root on your system is probably not the best plan, but you'd be surprised how often that actually is the case. Being able to make sure the OT and IT networks are not connected. One recent event was Pi Historian, which is a data collection system, became a path between the OT and IT network, and making sure those were separated was actually a critical thing that had to be done. Mobile media and internet, being able to actually know what should not be talking to what within the devices and places. And also even things like phishing emails, exploits of connections, accidental things that happen, just understanding where those different pivots that can come deeper into the industrial control system. Again, this is where all the planning is important. Understanding where those pivots can happen is your first big step to actually fix it. So getting deeper into the network is key for getting up to those large-scale events. So preventing that from happening starts at the very basic level where you access credentials are stolen or internet-to-internet devices have happened. So next slide. So defense in depth, I think, is the next slide, and it's a common term that's used, which is a combination of all these reports. And I'll just say this very quickly, that defense in depth is essentially protecting the system from the inside out. And so making sure that all these layers are addressed from down to the single component level up to the systems level analysis. So last couple slides. So who does what do we care about? What is typical and new types of response capability that are coming about. The Defense Science Board also put together a guide of what different scales of adversaries are. So when someone's talking to you about an adversary and they're saying tiers, it's coming from this Defense Science Board world, where adversary tier 1 and 2 are essentially people that can use vulnerabilities that are known. So when you hear that there's a vulnerability in your printer, for example, the type of people that would use that are adversary tier 1 and 2. 3 and 4 are people that can discover new ones. So the people that have found that vulnerability and then used it are 3 and 4. And 5 and 6 is up to the nation state type level where creating vulnerabilities is possible. So stepping to the next slide. And I think this is just an example of the sort of work we're doing at the moment. Adversary tier 1 and 2 is actually generally mitigated by basic cyber hygiene, antivirus, and pre-planning for events. It's not something that necessarily you need advanced research on. All of the rules that you see in place of how you work with your computers are where that's actually happening. But when we move up to sort of 3 and 4 and 5 and 6, that's where there's actually a degree of work that needs to go on and coordination between government entities. People like the National Guard are trained in some of the 5 and 6 responses, for example. So as we step through these, there's different levels, and I think that the things in light white, which I'm not sure my next slide actually had them highlighted, the things that are here are talking about the sort of work that the national labs, DHS, DOD, and DOE are doing to essentially mitigate those bigger adversary tiers that we don't have necessarily as much protection against from the basic industry level. So you can go buy an antivirus and it is very effective, but there isn't necessarily a protection that is developed presently for some of the higher tier adversaries because they're creating that vulnerability themselves. So next slide, or next couple. So yeah, we have industry and then areas where utility and industries are working together. And then lastly, the last tier, if you click the thing, is where people like the national labs are working as well. So lastly here, I included sort of the 6 strategies that the DHS National Cyber Incident Command, I think is that acronym. It's also below in the slide if you want to take a look, where they had recommended strategies for utilities and for looking at, was partially where we started to talk about the distribution system, which is where NERC-CIP isn't necessarily always used. And so some strategies here just to give some advice on where we're at and what's useful for as a very first basic level of cyber defense for the system. So I think I have included on the last slide potentially some links. There's numerous guidelines and best practices where there's starting to be new developments in the distribution system. But that is me for today. So I hope that didn't bamboozle too many people. I'm happy to take questions for a little bit.